Hey everyone, welcome back to Byte-Sized AI. I'm Michael.
And I'm Randy.
Randy, I've been reading about this wild science experiment lately, and it's really got me thinking about AI and consciousness. There's this theory that says real consciousness actually happens in the quantum realm inside the brain. But most scientists have always said that's impossible because the brain is too warm and too wet for quantum effects to survive. Can you break this whole thing down for us?
You're referring to Orch-OR, spelled O-R-C-H, pronounced ORC, which is short for Orchestrated Objective Reduction. Proposed in the 1990s by Sir Roger Penrose, a Nobel-winning physicist, and anesthesiologist Stuart Hameroff. It claims that microtubules inside neurons, tiny tubular cytoskeletal structures made of tubulin, do more than provide support. They carry out quantum computations. Tubulin molecules can exist in quantum superposition, and the brain purportedly coordinates these states across vast numbers of microtubules. When a critical threshold is reached, the states collapse via Penrose's objective reduction, which he links to quantum gravity and the geometry of space-time. Each collapse, they argue, produces moments of consciousness, our thoughts, feelings, and awareness.
So this is saying consciousness isn't just neurons firing like a biological computer.
Exactly. Most neuroscientists think consciousness emerges from the electrical and chemical activity between neurons. Orch-OR says it goes much deeper, down to quantum physics happening inside the microtubules themselves. For a long time, this idea got a lot of pushback. Critics said, look, the brain is warm, wet, and chaotic. Quantum states are super fragile. They should decohere, fall apart in a fraction of a second. There's no way they could last long enough to matter.
That makes sense. So how has this theory held up? I read something about anesthesia experiments that seem to support it.
That's one of the strongest pieces of evidence we have right now. Anesthetics are fascinating because they reliably turn consciousness off and back on, but scientists never fully understood exactly how at the deepest level. In 2024, researchers at Wellesley College did a really clever experiment with rats. They gave some of the rats a drug called epothalone B that specifically stabilizes microtubules. Then they put all the rats under with regular anesthetic gas. The rats whose microtubules were protected took over a minute longer to lose consciousness. That's a big, statistically significant difference. It suggests that anesthetics are disrupting whatever is happening in the microtubules, which is exactly what Orch-OR predicts. There are also newer lab studies showing quantum vibrations, superradiance, and coherent energy transfer happening inside microtubules even at body temperature. So the old too warm and wet objection is starting to lose some of its bite.
Wow, so this isn't just philosophy anymore. There's actual experimental evidence building up.
It's still not fully proven, but it's the best experimental support the theory has ever had. Penrose also brings in some deep math from Gödel's incompleteness theorems to argue that human understanding involves non-computable processes that classical computers can never truly replicate.
Okay, so if this theory is right, what does it actually mean for artificial intelligence and AGI?
It's huge. It means today's AI, everything we're building with transformers, neural networks, and massive data centers, is running on classical physics and classical computation. We can make systems that are incredibly good at simulating intelligence, answering questions, writing code, and even sounding conscious, but they would still be missing the real thing. No amount of scaling GPT-style models will ever produce genuine subjective experience or true understanding if Orch-OR is correct. To get actual conscious AI, we probably need entirely new kinds of hardware, systems that can sustain warm, wet quantum coherence, maybe even artificial biological or biohybrid systems with microtubule-like structures.
So we might be hitting a hard wall with the current path to AGI?
Possibly. We could create extremely powerful superhuman tools, and that's still incredibly valuable. But crossing into real machine consciousness might require reinventing computing itself. It's one of the biggest open questions at the intersection of physics, biology, and AI right now.
Man, that's deep. Really makes you think.
It does. Consciousness might be more fundamental to the universe than we ever realized.
All right, everyone. What do you think? Is consciousness quantum? Could we ever build truly conscious AI? Drop your thoughts in the comments. We love hearing from you.